This is the testing setup for my water cooling for the laser cutter. What I have is one of those cheap orange buckets that you get at Home Depot, and it's claimed to be 5 gallons, and unfortunately I'm going to take it at its word. And I know that that is a source of error. And then I've got a cheap flow meter that I got on Amazon in line with the pump, and that's all that's in line with the pump. This is a thermocouple that I'm going to use later. This is the power to the submersible pump. And then down here I've got a board that is my reflow oven heater board, and it's got a thermocouple input in there on the end, right there. And then this connector was intended to be used by a servo motor, but it turns out it hooks up to the capture compare port on the PIC, which is the same as the PWM pin, so I'm going to be able to use that as a tachometer for that guy, which is good. And then for now, I've just got my logic hooked up to the flow sensor, and then I'm just measuring the frequency this way. So we've got 21 hertz is the pulse rate, and then we're going to time how long it takes to empty out that quote-unquote 5-gallon bucket. And I'm going to assume that it's 5 gallons, and I'm going to assume that the flow rate's going to be the same when I restart the pump. And if the PWM signal stays the same at this 20 hertz, then I'll know how many seconds it takes to empty 5 gallons and what the PWM rate is, and I'll be able to figure out how to map the rate to the flow, kind of. I'll at least be able to know in very rough terms how much water is flowing through the laser. So I'm going to set the camera up on a tripod, redo the tubing so it's not in a loop, and then time how long it takes to empty 5 gallons. We're still right around 20 hertz. So when the bucket's empty, we're done. So we're still going. There's a small amount of water leaking from the flow sensor, so I'll have to deal with that eventually, but it's fine now. And then we're not flowing nearly as much water as I had hoped. That's pretty sad, really. I don't know if that's going to be good enough. There it is. Almost 15 minutes. So, it's about 3 minutes a gallon. I'll have to do some research to find out if that's anywhere near enough. My gut tells me no. So after yesterday's test, I was pretty disappointed with the pump's flow rate. I got only about 1 gallon per every 3 minutes, and this might be difficult to see. This is 185 gallons per minute, or sorry, gallons per hour pump. So it should be more like 3 gallons per minute, not a third of a gallon per minute. So I've done two things. I got rid of all of that extra tubing. Now I'm just using one single big tube. It's only about 2 feet long. And I'm also going to do it without the lid, because I figured that it's very likely with this lid and all of these holes being closed that there wasn't the ability to replace the lost volume of water with air. So it was probably putting extra strain on the pump. So between those two things, I'm hoping to actually evacuate this bucket in about 2 minutes. So I'm going to fill it up and then we'll check it out. And start. So already the flow rate out of the tube is much, much better. I don't know if you can see that very well. That's a pretty considerable amount of flow. Two minutes 45. That's it. So that's a lot better. Okay, so that last test was encouraging. Now I'm going to start putting things back one by one to see at what point it starts to perform poorly. So what I've done is I've left the simple stub of a hose in there, but I've put the lid back on the bucket. So right now I'm testing whether the lid of the bucket provides enough of a impediment to the water flow that it's going to prevent things from working. Now it's going to be a closed loop system, so that's not going to matter in the end, but for now I need to know if I can just do the testing. And I suspect it's going to be the tubing anyway. So I'm going to plug it in and we'll get going. Well, once again we have a good strong flow, so it's looking good to start with. $2.45, almost exactly like last time. So this is where the other ones ended. I'm going to lift up the lid just a bit. And it's barely gone down at all. So what I'm going to do while it's running is start unhooking things one step to the next and see if that flow improves. So it's still pretty pitiful. Still pretty bad. It's actually quite a bit better. Well, I think we have our answer. The flow meter just isn't going to work. Okay, so really quickly I want to take a minute to talk about these two pumps. This is the pump that came with the laser cutter. This is a pump that I bought separately. At first glance, I thought that there was no chance that the Chinese pump was going to be able to keep up with this one as far as flow rate goes, and also quality. So let's take a look at both of those things. I've done several tests with this pump with different loads. We just saw that, and I'll do another one with this one. This is an Eco Plus brand. I got it on Amazon. It's 120 volts, 10 watts, and it's saying it can do 185 gallons per hour. This one's 220 to 240 volts, 21 watts, and it was saying it's going to be able to do 1,200 liters per hour. So that's a fair amount more. I think that comes out to be like, I don't know, whatever. I'll post below how many gallons per hour that is. Yeah, so I'm concerned about two things. I'm concerned about that that's just an outright lie, and I'm also concerned that this is going to electrocute and kill me. So it does have double insulated mark. It does have a CE mark. Whether those are true or not, I don't know. This one's UL listed and actually has a code, so that is more traceable. I'm popping the covers off. It's pretty easy to see actually that they're really similar in construction. They both have exactly the same kind of twist cover to the impeller housing. They both have one of the bearings for the shaft in the front cover. They both are impeller designs, not that I'm surprised at all about that. If we take the impeller out of each of these, it's easier to see the size difference. So that's the impeller of the Amazon 185 gallon per hour pump. This is the impeller of the 1,200 liter per hour pump. And there's actually, I was surprised that there was that much of a difference between these pumps. This is a permanent magnet rotor on both designs. They use a brushless design and are basically in-runners. They have the coils on the interior of there, and they drive the shaft magnetically, so there's no possibility of seals going bad, trying to get the electricity in and out of the water, because these are submerged pumps. I can't open the back of this pump. It seems like it might be ultrasonically welded, and I'm not going to break it open. I don't care that much. This one I can pop right open, and you can see that it's potted hard. So that entire back cover is just covering up a giant slab of epoxy. It's using this really crap cord. I suspect that inside this cord is the same crap cord that was inside the transformer in the power video, and it uses these really crappy plugs that don't even have the hole in them. So I don't like this pump for a lot of reasons, but I may have to use it to start with, because I do believe that it will move a lot more water, and I'll just order a new higher flow pump. I'm going to do a test with this pump to see how quickly you can empty the 5-gallon bucket, just like the test I was doing with the other pump, and we'll be able to make good decisions with hard data. But for now, that's a double mini teardown. They both seem like they're safe, so I guess I just don't have that many concerns there. This is the last of our pump tests. This one is the Chinese pump that's rated at 1,200 liters per hour. That works out to be this 5-gallon bucket in a shade over a minute if it's running as claimed. The adapter that they provided with the laser cutter goes to roughly this size tubing, which is a separate adapter than the pump comes with. So it's one that looks like they included separately. So I'm sure that the flow restriction will limit the pump's output quite a bit. But the purpose of this test is to see whether it's worth using this Chinese pump and dealing with the 200 volts versus the pump that I got off of Amazon, which of course is still a Chinese pump, but whatever. If this significantly improves over the other pump, the Amazon pump, then I guess I'll just have to deal with the 200 volts for a while. I'll probably still replace it eventually anyways. I don't really want 200 volts in my water, but, you know, whatever. Okay, so I'm going to do the same deal. I'm going to turn on the pump and then start the timer, and we'll see how long it takes to drain. Okay. And there we go. Now my arc P test, I'll call it, is showing me that this pump is producing a little bit more flow than the other one did. So that's positive. I'm not sure if you can see the iPhone screen there, but we just passed 35 seconds. I don't think there's a chance that it's going to empty that in the next 15 seconds. I'm going to guess it's going to end up being about a 3-minute. And 3:45. Well, now the time has come to fill the water system. So I apologize for the quality of the video. It's night and this room is dark and very cramped because this is the only place I have for it. So there's my bucket. I've labeled the ports. There's the output port that hooks to the pump, the return port that is just open, and the purpose of that is because I wasn't able to use the flow meter. I wanted to be able to hear the water trickle, which would give an audio or an audible indication that the water's flowing, and I can sort of develop an intuition for what that sound is supposed to be. I've got this bucket in a large Rubbermaid. The idea of that, I learned that in home brewing, spills happen. And if you put the thing that can spill inside another bucket that can hold all of that liquid, then your spills don't end up in your carpet. So these hoses go around, up, and into the back of the unit. And there's the water input and output ports. And the input port comes up and around, and it goes to the fully reflecting terminal and the 20,000 volt terminal of the laser tube. And the return comes from the output coupler and the ground end. So I'm going to dump in enough water to cover the pump down there, and then I'm going to flick it on with the camera pointed at the laser tube, and we'll see what it's like to fill this thing up. So this is a bit of a moment of truth. I'm not going to lie, I'm fairly nervous. I've got the water pump hooked up to the transformer, so I've got a switch, and here goes nothing. Okay, definitely got water flowing in. Oh wow, the water jacket is only that inside bit. And there's the return. Can still see a bubble moving down the tube. I do wonder how long it will take the air to evacuate out of the system. Another interesting thing is that the output coupler link here actually has its own cooling loop, which is pretty interesting. That water bubble is still moving through. I suspect that might take quite a while. I'm thinking about putting a thermocouple, taping a thermocouple in this area somewhere to measure the tube temperature and log that for the first little while. You can see I got some of that bubble out. Certainly not all of it. I'm not sure what it will really take to get all of it. I tried lifting the machine up on an edge, and that definitely helped. But yeah, there's still some air in there. I did end up putting that thermocouple on the laser tube. This is the output. This is a really cheap Case Modders thermocouple temperature display. It came with a really thin thermocouple, which is nice, and I just took some Kapton tape, taped it to the end of the laser tube near ground. I'm not sure if thermally that's the best, but I like the idea of not having 20,000 volts capable of arcing over into this system. That wouldn't be fun for anyone. One thing that I would definitely change, the return line into the bucket I just left hanging so that I could hear it trickle. Well, I don't really hear it trickle because the bucket is so full. It actually holds just 5 gallons. But there is an air gap in there anyway. So what happens is when I turn the pump off, water siphons through the pump, through the laser tube, through all the tubing, and it pulls air out into from that air gap into the laser tube. So every time I turn the pump on, I have to get all the air out, and that's a pain in the ass. So what I should do is get another tubing adapter, and make sure that both sides end up in the water, and that way it can't siphon out. I've got the pump on 110 volts, and then I've got that thermocouple on 5 volts. So if I just turn on the transformer, those two things get power, so I can check the temperature and I can run the pump without turning the laser cutter on at all. And then the 220 goes into the back of the laser cutter there, and I have a separate power switch for that one. So that does work. That's it for this video. Next week we're going to be talking about optics. If you enjoyed this, please thumbs up and subscribe. Thanks.